DeepSeek shipped the official version of V4 Flash on July 31st, and after spending 2 days testing it through the API, I can tell you the agent numbers they published are mostly real. And that surprised me, because on paper this release looks like nothing changed. Same model string, same architecture, same size, same price. But the benchmark table tells a completely different story, and I want to walk you through why this small model is suddenly beating their own flagship preview. So here's the setup. This is not a new model. DeepSeek took the exact same V4 Flash that's been in preview since April, which is 284 billion total parameters with only 13 billion active, and they redid the entire post-training pipeline. No extra parameters, no new base model. All the gains come from teaching the same weights to plan better, call tools better, and survive long multi-step tasks without falling apart. And if you're already using DeepSeek-V4-Flash in the API, you got this upgrade automatically. Nothing to change in your code. Same endpoint, same model name, new behavior. Now the numbers, because this is the part that got my attention. On Terminal Bench 2.1, the preview scored 61.8. The official build scores 82.7. That is a 21-point jump on the same model size. On CyberGym, it's at 76.7. DeepSeek comes in at 54.4 and NL2 repo at 54.2. But the stat that actually matters most is this one. The official Flash now beats V4 Pro Preview on agent benchmarks. The small, cheap model is outperforming the 1.6 trillion parameter flagship preview at Agentic Work, their own bigger model. That tells you how much of agent performance right now is post-training, not scale. One thing you should know before you take those numbers at face value though. DeepSeek measured the code agent scores using their own harness, which they call DeepSeek Harness, running in minimal mode at max effort. And that harness isn't public yet. Harness choice alone can swing agent benchmarks by 10 or more points, so the honest read is this. The model got way better, that part is confirmed by third parties, but the exact numbers depend on tooling you can't reproduce today. Keep that in the back of your mind. The license situation stayed clean, open weights, MIT, unrestricted commercial use. The weights went up on Hugging Face the same day as the API update, so anyone can verify these claims on their own hardware. And with int4 quantization, Flash fits in roughly 100 gigabytes, which means 2 workstation GPUs can serve it locally with reduced context. That's not consumer laptop territory, but it's within reach for a small team, and that's rare for anything at this capability level. Pricing didn't move either, and that's the whole pitch honestly. Input is 14 cents per million tokens on a cache miss. Output is 28 cents per million. But cached input drops to about 1/3 of a cent per million tokens, and DeepSeek caches automatically on disk with 0 code changes. For agents, that cache pricing is everything. Agents resend the same system prompt and the same context over and over on every turn, so most of your real-world bill lands on the cache hit rate. Long-running agent loops on this thing cost almost nothing. Okay, enough numbers. Let me show you what it actually generates, because I ran it through my usual set of front-end and 3D tests, and the difference from the preview is not subtle. First test, a landing page for a hardware brand where the model has to nail the company's visual identity and present a product cleanly. It got the product presentation right, scroll animations, typography, section layout, all solid. The brand colors drifted a bit from the real thing, so it's not perfect at identity matching. But when I gave it a more detailed prompt describing the exact style I wanted, the output jumped a full tier. That's a pattern with this model. It rewards specific prompts way more than most models I test. Next, I asked it to clone a desktop operating system inside the browser. And this is where you really see how much the post-training changed things, because I ran this exact prompt on the preview model back in May, and I still have that output saved. The preview gave me a desktop with icons that open nothing. Empty shells. The official build gave me a working file explorer, a notes app, a functional calculator, a terminal, and a settings panel where you can actually switch accent colors. It even coded a small first-person game in Three.js with sound effects sitting inside the fake OS. Total cost for that whole generation, about 2 cents. That's the sentence I keep coming back to. 2 cents. Someone in my Discord also ran an open-world driving game prompt on it. No external assets, everything generated from scratch. The result had drivable cars, a city grid, basic pedestrian logic, and working collision. It's crude if you compare it to a real game, obviously. But 6 months ago, no model at this price could hold that much game logic together in a single file without the whole thing collapsing. The 3D generation is honestly the strongest category. I asked for an isometric cozy room at night in Three.js, and it produced proper warm lighting, furniture with actual geometry, and a soft ambient glow. Small quirks, sure, but usable. Then I asked for a full solar system, and it placed every planet correctly, kept the asteroid belt between Mars and Jupiter, and attached an info panel to each planet on click. That kind of factual attention inside a code generation task is where cheap models usually fall apart, and this one didn't. SVG is decent, but not flawless. I requested an animated city skyline with moving traffic and a boat in the harbor. The skyline and the boat animation came out clean on the first shot. The cars rendered in the wrong layer, floating above the buildings. So one-shot generations still need a cleanup pass sometimes. For a rally drift simulation, it built a track, spectators along the barriers, dust particles, and physics that were roughly right. Basic but coherent. And a low poly forest scene prompt gave me something that looked like an early 2000s adventure game, which is about what I expected. Other open weight models do that specific style better, but they also cost more per run. Now let's talk about where this sits against the competition, because that's the real question. Against GLM 5.2, DeepSeek's own comparison table has Flash ahead in basically every agentic category, and my debugging tests back that up. Both models solve the same bug fixes, but Flash does it noticeably cheaper. Against Kimi K3, which is roughly 10 times larger, K3 still wins on polish, cleaner typography, smoother scroll work, better taste overall. But Flash lands somewhere around 90% of that quality, and my full test run of 6 builds with 8 QA passes came in under 10 cents total. At that ratio, K3 has to be meaningfully better to justify itself, and for most tasks it isn't. Against the top closed models like Opus 4.8, Flash loses on raw capability, no question. It just doesn't lose by enough to ignore the price gap, which is enormous. There's one more thing in this release that I think matters more than any benchmark. The official Flash speaks the responses API format natively and was specifically tuned for codec-style harnesses. DeepSeek is clearly not positioning this as a chatbot. They're positioning it as an engine you drop into an agent framework. And that matches my experience, because raw API calls give you good first outputs, but inside a proper coding harness with retries and validation, the model performs a full level above what the price suggests. Which brings me to the honest downside, because there is one and nobody talks about it. Iteration consistency. The first generation is often excellent. Then you ask for a revision, and the second or third output sometimes comes back weird. Incomplete files, broken pieces, quality dropping for no clear reason. It's not every time, but it happened enough across my tests that I'd call it a real pattern. So my practical advice is, don't use this thing raw for iterative work. Put it inside a harness that can validate outputs and retry, and the inconsistency mostly disappears because the framework catches the bad runs. A few housekeeping notes if you want to try it. The upgrade is API only right now. The web app and the mobile app are still running the old setup, so you have to go through the API or a router to touch the new build. The old DeepSeek chat and DeepSeek Reasoner model names died on July 24th, so any legacy pipeline still pointing at those is already broken. And DeepSeek says the official V4 Pro is coming as soon as possible, which based on the pattern here is the release I'm actually waiting for. If post-training alone did this to Flash, the same treatment on the 1.6 trillion parameter model could get genuinely close to the frontier. So here's my overall take. This release proves that the cheap tier of AI models is no longer the compromised tier. A 13 billion active parameter model matching last generation flagships at agent tasks under MIT at 28 cents per million output tokens changes the math for anyone running agents at volume. It's not the smartest model you can buy. It's probably the smartest model you can afford to run all day. Test it inside a harness, watch the iteration quirk, and check your cache hit rates because that's where the real savings live. I'll put all the links in the description. See you in the next one.